Hello students, we were doing Bohr's model of atom and he gave his model of atom based only for hydrogen atom, and every information he gave in his model by taking hydrogen atom as a reference. Students, in different models like J.J. Thomson's model, we studied his drawback that he was not able to give atomic spectrum. In the Bohr's model, after doing it, we will take the drawbacks, and in that also we will study that he gave atomic spectrum of hydrogen atom only, not for the rest of the atoms. So in this class I am telling you students, what is this atomic spectrum? What do we mean by the term spectrum? It is not there in the syllabus of 11th class, but everything is related with it. That's why I am taking this topic in this video. So atomic spectrum. Firstly, I am telling you the meaning of spectrum. As you have done in physics, whenever a white light from the sun, light from the bulb, light from the tube light, white light whenever is passed through a slit, a small hole is there, slit, and if taken on a screen, this prism, it splits into several colors, as you know students, Vibgyor. So what is happening here? Splitting of light, one light into many other radiation of different wavelength. This phenomena we call as dispersion. This is not spectrum, students. This splitting of white light into many colors, we call this phenomena as dispersion. And due to dispersion, when these lights of different wavelength are taken on a photographic plate, we obtain some definite pattern over the photographic plate. So that pattern which we are getting after dispersion is called spectrum. So this is called spectrum, students. The pattern which we are getting after dispersion. Okay, students. Here, if I give you the example like rainbow. Rainbow is a pattern in which you can able to see 7 colors. So that is due to dispersion only. And that 7 colors which you are able to see, that is called spectrum. So I think that what is a spectrum, you are knowing now. Now I am telling you, atomic spectrum can be of 2 types: emission spectrum and the absorption spectrum. Emission meaning, students, whenever emitted light, emitted radiation is taken on a prism. Emitted light like sunlight which is coming to us, that is also emitted light. If you heat iron rod, when at very high temperature, when it is heated at higher temperature, it start emitting out certain radiation and it start glowing. So that is also emitted light. So we are doing emission spectra. What is it? Emission spectra. The emission spectra can further be divided into 2: continuous emission spectra and the line emission spectrum. What do we mean by continuous spectra? Continuous, rainbow comes in it. What is it actually? Here I have drawn a figure, students, you can see. Like sunlight or the white light, when passed through a slit on a prism, it splits into different colors and Vibgyor is seen. You can able to see, students, Vibgyor is observed. Like in case of rainbow. If you observe rainbow, students, all the colors are so intermingled into each other, so mixed into each other, that you cannot able to differentiate different color region, like where is red exactly, where is blue exactly, or yellow or violet. All the colors are intermingled into each other, or we can say all the colors are continuously placed without any gap. So, this type of spectrum which we are getting is called continuous spectrum. All the colors are so continuous that you cannot have a gap in between. Now, the second part of emission spectra is line spectra. Line spectra is given by volatile substances or by a particular element. Okay, particular element. Like if we heat volatile NaCl salt on a Bunsen flame or any flame, again it start glowing, and when that light is taken on a prism, we will get two bright colored lines interrupted by dark zones. Two bright lines, white जो दिख रहा है आपको, two bright lines are observed interrupted by dark zone. So that bright light are given by actually sodium. Sodium lamp always gives yellow colored light when heated or given electric spark, and that two lines or the light which we are getting are associated with two different wavelengths, that is 5890 angstrom and 5896 angstrom. Okay, students. So, in the case of line spectrum, we are getting bright lines interrupted by dark zones. Here I have written, students, that line spectrum is specific for a specific element. Every element possesses specific line spectrum. That means its line which we are getting in the spectrum on the photographic plate, that lines are associated with some fixed wavelength. Like in sodium, we have done that 5890 angstrom and 5896 angstrom wavelength light are observed. Lights are observed. Okay. So, if we are taking some different element, it will give some different wavelength lights. So, we can say that this line spectrum, which we call as atomic spectrum also, is taken as fingerprint of the element. Like you know, students, no two person can have same fingerprint. Similarly, no two elements can have same line spectrum. All the elements possess different line spectrum. Is it clear, students? Next, I am taking is line spectrum for hydrogen. Hydrogen is also an element. So we are taking line spectrum for hydrogen. And I am telling you, students, that Bohr studied the atomic spectrum of hydrogen only, or hydrogen-like species only. Okay, he was unable to give the spectrum of other elements, multi-electronics elements. Okay, only he gave spectrum of element which contain single electron. So when he heated hydrogen gas by providing electric spark at lower pressure, high volt current when given, it start igniting. And when that radiations are taken on prism, different lines, bright lines were observed associated with different wavelengths. And as the set of lines or the group of lines were observed, different scientists studied that lines and gave that lines a particular region and gave their names also. Like first set of series of bright lines which were obtained in the hydrogen spectrum was that lines were termed as Lyman series. That series of line were termed as Lyman series, Lyman, Lyman series, on the name of scientist, because Lyman studied that brighter line in the hydrogen spectrum and he gave his name for that lines. So we are calling that lines as Lyman series, and that lines fall in ultraviolet region. Whatever is the wavelength of ultraviolet region, that wavelength is there in the Lyman series of hydrogen atom spectrum. Second set of lines that were studied by Balmer, 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 and these series or set of lines lie in visible region. We studied electromagnetic spectrum on the basis of different wavelength and frequency. So here this Balmer series is lying in which wavelength setup? In the visible region. Next set of line studied by Paschen. So that series of lines are called Paschen series. Then the next is bracket, BRACKETT. And the last set of lines, brighter lines which were observed in the hydrogen spectrum, was studied by P. Fund. And these three, Paschen, bracket, and P. Fund series lie in infrared region. On what basis we are giving the position to these all radiation? On the basis of the wavelength difference. Okay, students? After giving these all series, Rydberg, one scientist, calculated their wavelength, exact wavelength. He gave a formula to calculate wavelength of different lines, and he gave that formula in terms of wave number, nu bar. If you remember, students, nu bar is the formula for calculating wave number. What is that formula which was given by Rydberg? That formula is 1 by lambda. 1 by lambda is actually nu bar. 1 by lambda is equal to nu bar is equal to R 1 upon N1 square minus N2 square. What are these numbers, N1 and N2? These are whole numbers, 1, 2, 3, 4, any. And what is this R? R is the Rydberg's constant, and it is having fixed value, that is 109,677 centimeter inverse. Okay, students. Now I am telling you, students, what is this N and what will be its value. Remember, students, this N1 and N2 for every series is different. If we are taking Lyman series, N1, actually, students, if we are considering hydrogen atom, in the center nucleus is present, around the nucleus different orbits are there, K, L, M, N, O, P, Q, R, S, and so on. So that orbits actually are the N1, N1 meaning which orbit? K, N2 meaning L, N3 meaning M, N4 meaning N1 is equal to 1 meaning K, N1 if I am taking 2 that means it is L, N1 if I am taking 3, K, L, M, then N, like that. So in the Lyman series, the ground state of electron, ground state N1 is always 1, and it can get excited to second, third, fourth, and so on. But its position will start from 1, K shell. If we are taking Balmer series, N1 will be equal to 2 and N2 will be, now 2 के बाद क्या आएगा, 3, 4, 5. पार्शियन के लिए N1 हमेशा 3 है, दैट मीन्स के एल एम से शुरू हो रहा है इलेक्ट्रॉन, और M से फिर कहाँ जा सकता है, N पे भी जा सकता है, O पे भी जा सकता है, P पे भी जा सकता है. ब्रैकेट में N1 जो है हमेशा 4 है and N2 can be 5, 6, 7 and so on. P fund N1 is always 5 and N2 can be 6, 7 and so on. Okay, students. Now one question arises, one question should come in your mind, that in the hydrogen atom only one electron is present. If you know, students, in the hydrogen atom only one electron is present, then why we are getting so many lines in the hydrogen spectrum? So answer is if we are not taking hydrogen atom alone. Hydrogen exists as hydrogen gas. And a sample of gas, if we are taking, it will contain infinite number of molecules in a sample, and that infinite number of molecules in turn contain infinite number of atoms, and infinite number of atoms will contain infinite number of electrons in them. Like hydrogen gas, if electric spark is given, it will split into atoms. Then atom will ionize to give out electron. And in this way, we can say that infinite number of electrons will be present in a sample of gas which is ignited by the electric spark. And thus, every electron is absorbing different amount of energy. Like if you are keeping water in a container over a gas burner, each of the molecule is not getting same amount of energy. Every molecule is getting different amount of energy and thus different temperature it is absorbing. Like molecules which are present above, they are absorbing less amount of energy. Molecules which are at the bottom receive more amount of energy, and so on. So that is the reason, students, because a sample of hydrogen gas contain infinite number of electron and each electron is absorbing different amount of energy. Thus they are getting excited to different levels, and this is the reason that why we are having many set of lines in the spectrum of hydrogen. Like here I have given you a diagram also, students. Like here, if we are observing, these are the levels N1, then N2, then N3, N4, N5 and N6. So in the case of Lyman, that is the first series as you have observed, this is Lyman. So where N1 is always 1. Like if electron is going to any level but coming to 1 only, that means its starting level is 1. Okay. And in case of Balmer, here you are observing, students, 1, 2, 3, 4, 5, 6. From 6 also it is coming to 1. From 5 also it is coming to 1. From 4 also it is coming to 1 only. So N1 here is 1 and N2 can be 2, 3, 4, 5, 6 or so on. Similarly, in case of Balmer series, you are observing, students, electron is ultimately reaching to which level? N is equal to 2. So here for Balmer, N1 or the ground state for the electron, ground state I am saying, N1 is the ground state. So N1 for Balmer series is 2 always, and on excitation electron can move to any level. That's why it is returning back to second from 6, From 5 also it is coming back to second. From 4 it is coming back to 7. From 3 also it is coming back to 2, I am saying. From this 6 it is coming back to 2. From 5 it is coming back to 2. From 4 it is coming back to 2. From 3 also it is coming back to 2. So its ground state is 2. In the Balmer series, ground state is 2, and the excited state, which we are representing by N2. N2 is the excited state of the electron. That can be any in the Balmer series, which is lying in the visible region, students. Ground state is 2, but the excited state can be 3, can be 4, can be 5, can be 6, can be 7, and so on. So this is the Rydberg's formula. Paschen also I have drawn here. It can be same for bracket के लिए N1 जो है that will be 4 and N2 can be 5, 6, 7 and so on. P fund के लिए N1 is 5, N2 can be 6, 7, 8 and so on. Okay students, so in this way Rydberg gave a formula for calculating wavelength in terms of wave number. So this was the line spectrum, students, and line spectrum of hydrogen also we have studied. One more spectrum was there, students. In the beginning I told you that atomic spectrum can be of two types, emission spectrum and the absorption spectrum. So what is this absorption spectrum? I am telling you that also so that we can cover this whole topic today. Absorption spectrum. It is the spectrum when white light, which was previously giving you the continuous pattern, है ना? बिल्कुल intermingled थे सारे colors यहाँ, continuous pattern we were getting. But in the absorption spectra, white light is not directly taken on the prism. Firstly, that white light is passed through the vapors or some chemical substance, through the solution of some chemical substance is taken here and in a beaker or anything. When this white light is passed through that vapors of the chemical substances or the solution of chemical substances, and then that white light is taken on a prism. Now, if we are obtaining the spectrum, we will find that spectrum will not be continuous. That VIBGYOR, here VIBGYOR will not be continuous. It will be interrupted by dark zones. Some of the components will be missing. So where that components are going on, and that missing components is producing dark zone, dark band here. That missing component is actually absorbed by this chemical substance. Some of the components of this white light from that VIBGYOR get absorbed by these chemical substances depending on the nature of that substance, and is allowing only some of the component to go through in the form of this radiation. And that's why when this radiation is splitting after passing through the prism, is producing dark bands here on the photographic plate. And that's why instead of continuous pattern, we are getting interrupted pattern. And this is called absorption spectrum because some of the components are getting absorbed by this chemical substance. So students, this is called atomic spectrum, and J.J. Thomson was not able to give the atomic spectrum. Same we will study in the next video about the drawbacks of Niels Bohr model of atom also. I will tell you that. Students, I am observing that many of you are not watching the videos and not making the notes. Students, it is mandatory for all the students to write down the notes, and I am ready to tell you your queries, whatever you are having. So watch these videos very seriously and make notes in your fair copy. Thank you, students.